Fusion Mobile, quality e-learning experience on the go.
Okay, my dear, welcome to Physics Clinic of Fusion Mobile Nigeria Limited. We are handling the topic fundamentals of motion. By motion, we simply means the movement of a body from one point to another with respect to a particular observer in a given time interval. Motion involves a change in position of a body with respect to time. There are two basic studies of motion. The first one is called the kinematics, which deals with the study of the character of the motion. How is that particular body moving? Is it rolling? Is it running? Is it walking? The character of that particular motion is treated by kinematics. While the second is the dynamics. Dynamics deals with what causes the motion. Example: pull, push, and any other kind of force that causes the body to move. So in motion, it is divided into two major branches: dynamics, which causes the motion, and kinematics, which expresses the movement of the motion. And there are four basic types of motion: random motion, translational motion, rotational motion, period, oscillatory or vibratory motion. We can now handle them one by one. Random motion. This is the movement of a body without a specified direction. This is the movement of a body from one point to another without a specified direction. Some people will tell you that it's a zigzag motion, but not having a direction simply means that the body moves without a specified direction, like this way, with the rest strokes moving, going from anywhere to anywhere without having a particular place we can say that this is what it will be or where it will be. Example of random motion: movement of a filled balloon in air. Brownian motion. By Brownian motion, we mean the movement of tiny particles suspended in fluid. Fluid here can be gas or liquid. Example: dust particles suspended in air are example of Brownian motion. Particles alongside with smoke on a burning heap is also an example of Brownian motion. So all Brownian motions are random motion. We'll bring it back to translational motion. Translational motion is the movement of a body from one particular point to another on a straight platform without rotation. Example: if this is point A and this is point B, and this body moves from point A to point B without rotation, and that body is a rigid body, something you can hold, not like water, not like gas, more of like a solid, something you can hold, and this rigid body moves from a point to another, example A to B, without rotation, we consider that motion as a translational motion. Then rotational motion. This is the movement or concentric movement of a body about a fixed point or axis. By concentric, we mean a circle inside a circle. Example: consider your fan blade. You have somewhere here with the rest spots there like an engine. Then you have the fan blade moving around that particular rest spot this way. This particular spot here is considered a circle, while the one moving around it is also a circle. So when it moves round about this particular fixed point at the center, we consider it as concentric, and movement about a concentric is considered as rotational motion. Example of rotational motion: the movement of an automobile wheel round the particular point where it fixed, your fan blade, fan belt, etc. We have oscillatory motion. This is the to and fro movement of a body about a fixed point. By to and fro, if we consider this to be a point there as a fixed point, and from the point we have this is a thread at this point, and from this point it makes a movement to this point. This particular way is considered maybe to, and when it's returning back we consider it as fro. And these two motions complete made up of what we call oscillatory motion or vibratory motion or periodic motion. The complete to and fro movement of a body about a fixed point is called oscillatory motion. Example of oscillatory motion: the movement of a simple pendulum, which is in our lab. Now we consider some parameters that we must know about before we talk about motion. Example: we discussed quantity earlier on, but quantity we said are divided into two: fundamentals and derived. Now with another concept, we have scalar quantities and vector quantities. This description now is based on direction. Scalar quantities are those quantities that have only magnitude or size but no specified direction. Example: energy, distance, temperature, mass, speed, etc. While a vector quantity is one which has direction as well as a magnitude. Example: displacement, velocity, force, acceleration. Now talking about relative motion, my dearest, please, in case of exam and they said state types of motion, relative motion is not among types of motion. Rather, it's a description to tell you what happens in a particular scenario of system of motion. I will use an example. If a man is sitting in a bus and the bus is moving, and another man is walking alongside the roadside, both have motion. The motion of the man in a bus moving relative to the motion of the man by the roadside walking is considered relative. And since it's considered relative, we call it relative motion. So we'll say that relative motion is a change in position of a body with respect to another. Parameters of motion. The first one, we talk about distance and displacement. Then we'll move on to speed and velocity. Then we talk about acceleration. Let's handle them one. Distance and displacement. This is the length difference. For example, distance first is the length difference covered in motion through the path of the motion. Example: if I have here to be the point A, and this body moves this way and finally gets to this point here, B, the length we must measure around this particular column we have till we get to the point B from A is considered as distance, while displacement is the length difference made from A to B but in a specified direction. The straight line there notes displacement, while the other column that is not straight specifies direction. Speed and velocity. Speed is the rate of change of distance and is a scalar quantity, while velocity is the rate of change of displacement, is a vector quantity. Mathematically, both are given as v equal to distance all over time. So in symbol, we'll say that v is equal to x all over t. Acceleration. Acceleration is the rate of change of velocity with respect to time. It is not velocity over time, no, but change in velocity per time. So we can say that mathematically, acceleration, small letter a, that is the conventional way of representing acceleration with a small letter a, is equal to change in velocity all over time. And the SI unit of acceleration is meter per second square, while that of velocity is giving us meter per second, while that of distance and displacement is given in meters. So we take it to the point of acceleration, where we'll say that A is equal to delta V over T, and that the unit of acceleration is meter per second square. We have handled dimension earlier on, my dearest, and I would like you to get me the dimension of velocity and acceleration. And also, before we move into the next step of motion, open up your book and read out for me all Newtonian motions. We'll get to that. Thank you, and meet you again when we'll be talking about work, energy, and power.